Next question, comprehension. A phenolic compound X C7H8O2 on mild oxidation gives a highly volatile oily substance, and Y is mentioned as highly volatile. And this X also forms Z on reaction with dimethyl sulfate methylation in alkali, and Z with hot KMnO4 gives product P, which then reacts with bromine water to give Q containing about 72% of bromine in the Q. So this is given as the passage. Now let's see what are the questions asked. So which one of the following statements is correct? Highly volatile oily substance is orthohydroxybenzoaldehyde. So we are given X as C7H8O2, and this is on mild oxidation is giving a highly volatile oily substance Y. Now no doubt this orthohydroxybenzoaldehyde, due to intramolecular hydrogen bonding, there exists a intramolecular hydrogen bonding between oxygen of the carbonyl group and hydrogen of hydroxy group. Hydrogen attached to oxygen will be involved in hydrogen bonding, and because of this intermolecular hydrogen bonding is reduced and association is prevented, and thereby this exists as a single unit with low molecular weight than when association occurs, and thereby the molecular weight of it will be relatively less and becomes highly volatile. So it is a volatile oily substance, thereby Y is orthohydroxybenzoaldehyde. If Y is to be orthohydroxybenzoaldehyde, which is the mild oxidized product of X, then what will be the X? So this aldehyde group which is there must have been oxidized product of X. In other words, this X may be orthohydroxybenzyl alcohol. So that on mild oxidation, this primary alcoholic group is getting oxidized to CHO, and in this Y, there being intramolecular hydrogen bonding, it exists as oily substance. So thereby highly volatile oily substance, A may be right. Let's check the other answers. P is metahydroxybenzoic acid. P is metahydroxybenzoic acid. What is P? So in this sequence of reactions, what is P? P is here. That is, the original X is subjected to methylation, then Z is formed. Z is treated with hot KMnO4, one of the strong oxidizing agents, to give P. So we need to know what is P now. So if X is OH and here is the ortho position hydroxymethyl group. So on methylation, when we take dimethyl sulfate in the presence of alkali OH minus, this H will be replaced by methyl group and we get OH remains, and this becomes CH2OCH3, and this becomes now Z. And what will be the oxidized product of this when subjected to oxidation with KMnO4 under heated conditions? So this particular group, which is the side chain on benzene ring, when subject to oxidation with KMnO4, it gets oxidized to acidic group. So it becomes orthohydroxybenzoic acid. What is it called? Salicylic acid. What is it? P. So therefore salicylic acid is formed. It is orthohydroxybenzoic acid. So P in the above sequence of reactions is orthohydroxybenzoic acid. But what are the options given? P is metahydroxybenzoic acid. What we got? Orthohydroxybenzoic acid. Therefore it is wrong. Final product Q is 1,3,5-tribromophenol. We need to check what is Q. So Q is obtained when P is treated with bromine water containing 72% of bromine. So what happens when P is treated with bromine water? We need to check. So this is the P. This is treated with bromine water. And here the OH group is there. As it is phenolic, the ring is activated and it becomes, when treated with bromine water, tribromophenol. So 2,4,6-tribromophenol is nothing but Q. And if you want to cross check whether it contains 72% of bromine or not, we need to find out the molecular weight, and 3 bromine atoms are there, from where we need to work out. So Q we are getting it as tribromophenol. What is given in the options? Final product Q is 1,3,5-tribromophenol. But what is that we got? 2, this is first position, this is second, third, fourth, fifth, sixth. We got what? 2,4,6-tribromophenol. Therefore, C, final product Q is 1,3,5-tribromophenol is wrong. Then what about Z? Z gives iodoform test. Is it true? But what is Z? Z is this. And we know that Z does not give iodoform test. Thereby, when we go for the D, it is given Z gives iodoform test, but it actually does not give. Therefore, this is wrong. So then what is left? What we have assumed, this orthohydroxybenzoaldehyde due to intramolecular hydrogen bonding exists as unassociated molecule and thereby volatile in nature. So thus A is the answer.